I got a question on number 3 from homework number 2 over limiting reactants. So, starting with iron and hydrochloric acid. She has a microphone. She has a microphone.
Did your husband get his podcast on?
She did. He did. He did. She did. Yes. All right, so iron and hydrochloric acid react together. If you have iron, this is a metal with a positive charge. And then I have hydrochloric acid where hydrogen has a positive charge and chlorine has a negative. So when iron is introduced to this compound, it is going to try to, oh, sorry, it's frozen. That's better. Okay, when iron is introduced to that compound, iron is going to try to replace who? Hydrogen, because they're both positively charged. If you're not sure if that reaction is going to occur, that's when you're looking at your activity series. So on here, iron is right there, and hydrogen is down here. So iron is higher up on the activity series, which means that this reaction would occur, which is why I was able to ask you follow-up questions if that wasn't already obvious. And so what you end up with is FeCl2, because iron has a +2 charge according to this. And then hydrogen is kicked out and now single. But when hydrogen gets kicked out, it is diatomic. So then I need to balance my equation. I need a coefficient of 2 in front of HCl. And then I need a coefficient, that's it, right? 2 hydrogens, 2 chlorines. And then no coefficient in front of iron because I only have 1. Cool? Good with that. Okay, so then the question says, when 25 grams of iron are mixed with 25 grams of hydrochloric acid, which is the limiting reactant? So iron, if I had 25 grams of that, I would bring grams of iron to the bottom. So I need to look at the periodic table for the molar mass of iron, which is 55.845. So 55.845 grams of iron per 1 mole of iron. Then I would need to turn iron, so turn moles of Fe into moles of either one of my products. Here's where it helps you to look ahead to figure out what product you need to make. I could turn it into FeCl2 or I could turn it into H2, but here I have follow-up questions specifically about hydrogen gas. So the product that is going to help me to turn it into at this point in time is hydrogen gas. So I'm going to say moles of H2. Sometimes you'll have follow-up questions about both and you'll have to calculate both, but start with hydrogen gas for now. So then I would use the coefficients. I have a coefficient of 1 in front of H2, or really no coefficient here, and the same thing with that one. My grams of iron cancel, my moles of iron also cancel. So then I have to do 25 divided by 55.845. So 25 divided by 55.845, and that gives me 0.44766. So this equals 0.44766, which would, with sig figs, be 0.45 moles of H2. Okay, so that's how many moles of H2 I could produce from that much iron. I used a ton of room for that, so I'm going to like zoom way in and just like write really small over here for 25 moles of, what is the other one? I already forgot. Hydrochloric acid? Yes. Okay, so 25 grams HCl. I would bring grams of HCl to the bottom, and then I need to calculate the molar mass of hydrochloric acid. The molar mass is going to be per 1 mole of hydrochloric acid. Then I would bring moles of HCl to the bottom and moles of H2, my same product, on the top. I have 2 moles of HCl for every 1 mole of H2. That's my mole ratio from my balanced chemical equation. And then I need to calculate molar mass. So I'm going to take the molar mass of hydrogen, which is 1.008, plus the molar mass of chlorine, 35.45. And I got 36.458. 36.458. And then calculate this by taking 25 divided by 36.458 divided by 2, And that gives me 0.34286. 0.34286. Is that what I just said? 34286. Yes. Okay. So then rounding to 2 sig figs again to match my starting information. So this would be just 0.34 moles of H2. So then if I compare my answers, I was able to produce 0.45 moles of H2 using 25 grams of iron, or 0.34 moles of H2 starting with 25 grams of hydrochloric acid. So which one is my limiting reactant? HCl is limiting. What tells me that? What am I actually looking for when determining what's the limiting? Okay, yes, the amount of moles of H2 that I produced. This one is less, so this is my limiting. So the question B says, how many moles of hydrogen gas is produced? And the answer is going to match that. I don't have to do any math for this. It's just going to be 0.34 moles of H2. If you had chosen to calculate this product, then you would have to do extra math down here. So that's why I was smart and looked ahead. Because this is the exact thing that I calculated here, it's not like, oh, I'm guessing what it is. No, this is truly the amount that you're able to produce. So that is the answer there. And then how many grams of hydrogen gas produced? I can take 0.34 moles of H2, hydrogen gas, and then just turn that into grams. So I would take 1 mole of H2 for every 2.016 grams of H2. I know that it's going to be 2.016 because my periodic table has hydrogen listed at 1.008, but since it's H2, I double that. So then 0.34, so 0.34 times 1.008 equals 0.3, not that, sorry. I guess I got to double that, right? Times 2? No, wrong thing. Gotta start over. 0.34 times 2.016 is that 0.68544. So what? Was it the same answer? Yeah, it was. Yeah, I mean, I guess that's how math works. It's just multiply. Either way, okay, so 0.685, which would round to 0.69 moles of grams of H2. You could have also taken your 25 grams and started with that and then just turned it into this, but the rest of it, so it would have started with 25 grams of HCl, and the whole block would look the exact same as this one, but then at the end you would have tacked on the molar mass of H2 and gotten the same thing. Good? I do want to talk about example 2 while we're here. So first of all, what coefficients did you use there? 1, 1, 1, 2? Is that what you said?
Yes.
Okay, cool. So I trust that one. This one tends to confuse students because you don't have a good grasp of what the limiting reactant actually means. So this one says, if 10 moles of Na2O are used, I'm going to label it as we go. A little thinner. Okay, so 10 moles of Na2O are used with 6 moles of MgCl2, so 6 moles here, to produce 241.86 grams of MgO. So I'm going to put 241.86 grams of that are going to be produced, and 4 moles of Na2O remain unused after the reaction is complete. Which is the limiting reagent?
It's magnesium dichloride.
Not dye, but magnesium chloride, yes. How do you know?
Because it's the one with the lowest amount of moles.
No. No, how can you tell if something is the limiting reactant? So starting with the least amount of moles is not a thing. Definitely not that. Least amount of moles in your balanced chemical equation, also not that. It would produce the least amount of moles. Okay, but without even calculating anything, you should be able to look at the wording of this question and tell me that magnesium chloride is going to be limiting. But why? What?
Oh, because it says 4 moles of Na2O.
Yes, this part right here that says, where did that go? 4 moles of Na2O remain unused. If it remains unused, that means that it is left over at the end. So if I have leftover Na2O, that tells me not all of the Na2O was used up. So that must be my excess. So then I guess by process of elimination, you know that magnesium chloride must have been the one to run out. Then letter B says how much of the excess reagent is unreacted.
4 moles.
How do you know that 4 moles would be?
Because it stays at
Because that's exactly what it says. It remains unused. Unused means it's unreacted. So yeah, 4 moles. I didn't have to do any math for that one either. It's just about reading the question. And then it says how many moles of NaCl are formed. So if I want to know how many moles of this I would form, I'm going to use a different color. This one's already annoying. I need to start with my given information about the limiting reactant. I know my limiting is MgCl2, so I can start with the amount of MgCl2 that I started with, which was 6 moles of MgCl2. If I take moles of MgCl2 down here and put moles of NaCl up here, 2 moles of NaCl for my balanced chemical equation, and then 1 mole for my balanced chemical equation for MgCl2. 6 times 2 gives me 12 moles of NaCl. That is how many moles of sodium chloride are formed. You could also use the mass of magnesium oxide to figure out how many moles of NaCl are produced, so you would end up getting the same answer. So if you chose to do it that way, I'm going to zoom in a lot so I have more blank space and then kind of just erase some of these scribbles so that we're not getting all confused here. Just to show you what I'm talking about. If I were to take 241.86 grams, so 241.86 grams of magnesium oxide, because that's one of my products that was formed, I can take grams of magnesium oxide down to the bottom and 1 mole of magnesium oxide to the top. Keep going in your T-chart, so bring down moles of MgO and put moles of NaCl at the top. Between moles of magnesium oxide and moles of NaCl, I use my coefficients from the balanced chemical equation. So for every 2 moles of NaCl, there's 1 mole of magnesium oxide. Then I use my molar mass of magnesium oxide. So that would be 24.305 for magnesium plus 15.999 for oxygen. So 40.304 would go here. And then 241.86 times 2. Oops, I hit divided, not that. Times 2 equals that. And then divided by 40.304. 40.304 equals 12.0017. So with that, I would get 12.0017 moles of NaCl. And if I round to 4 sig figs to match this, no, 1, 2, 3, 4, 5, sorry, 5 sig figs. Okay, so that's 12.001 moles of NaCl. That is basically the exact same thing as the 12 moles that we already calculated. So either way that you chose to do it, you should have come up with 12 moles.